Good day, grade 8s, and welcome to mathematics. Today we will be looking at quadrilaterals and their properties. So the first thing first, what is a quadrilateral? Quad means four. If you go on a quad bike, the bike has four wheels. So a quadrilateral is any shape, 2D shape, that has four sides. Okay, only four sides. It doesn't matter how they look as long as it's got four sides. Then let's look at the different ones we work with in grade 7, 8, 9 and on. Okay, so first of all we have the definition. Polygons with only four sides and four angles. Obviously, a polygon, poly means more than one. So a quadrilateral falls into the group of polygons. However, a quadrilateral is a special kind of polygon that only has four sides and four angles. Okay, we have a square, four sides, four angles. Which one have you known for like 10 years already? Square. And after square, we have a rectangle. Those are the two that you are most familiar with. Then we have a parallelogram. Just look at the spelling of this one. I know, big word, so just learn it. Haha. Okay, next we have a kite. You've all seen kites, you know how to fly them. I hope you've tried that. A rhombus is next up, and a trapezium. Okay, so your trapeziums don't always look like this. They can be shorter, yeah, they can fall skew. This side doesn't have to look the same as that side, just keep that in mind. Trapeziums don't always look like this. Okay, the rest of them are all straightforward. They don't really change shape, except for the trapezium. Okay, next up, let's look at each of them on their own. Let's start with the parallelogram. This one is my favorite. It is also the one that is asked most often. So the important thing is that when they start the question with, here is a parallelogram, start by doing all of the properties that we're going to name. So take the parallelogram, sorry guys, very big word, and draw it in color. And then you start putting each of the properties that you know onto your sketch. When you do that, you'll see there's a lot of more information on the sketch that you've just put in there than what there was originally. Then, when you use a property, always remember to name the property, okay? And in this case, you will just state that it is a parallelogram, okay? So, there's a nice big parallelogram, and the first property we look at is opposite angles are equal. So opposite means you have to shake hands. This angle and that angle are not opposite each other. So when we look at opposite, it's the one that is across from it. Okay, so those two angles will be opposite each other as well as these two. So there's your first group that is equal to each other. Again, you guys know I like color, I like shapes. Put it in, name it, color it, highlight it. Make sure you know that those two are the same size. Next, we've got our nice little blue clouds. They are equal to each other. Okay, sometimes they only give you this angle and you can work out that angle. Sometimes they give you that one and you can determine that one. The next one is opposite sides are parallel. How do we indicate parallel lines? Parallel lines we indicate with little arrows on them. So this side is opposite to that side, therefore they are parallel. Remember, this property is usually not indicated with words, however the arrows are actually drawn onto your sketch. And that side and this side will also be parallel. Then our last property that we have to know right now, there is a lot more properties, guys. Please don't think this is the only ones, but these are the only ones you need to know now. Okay, next up we have opposite sides are equal. So if we have opposite sides are equal, therefore this side is the same length as this side. How do we indicate that? With singular straight little lines. That one and that one will be. So then we've got our first pair, little straight lines. Now the important thing is, you will see that with these arrows, there's one arrow and this one has one arrow. That means that those are a pair. So if we have another line that's also parallel, it also needs to have one arrow on it. Okay, this side is not parallel to that side, therefore this one doesn't have two arrows on. And the same applies to the length. Because this length has one line to indicate that that side is the same length as that side, then when we indicate this next one, because this is the longer one, and this side is equal to this one, we can't just use a single line. Therefore, we have to use double lines. Now just look at this parallelogram. From the information that is on the sketch at the moment, is there things that you can obviously determine without having all of this information? For example, if they only give you that angle, only, no other angles are given to you, then you can obviously use the property opposite angles are equal, and you can determine this angle there. Okay, so now we've got two angles. The next one that we have to determine is this blue angle and that blue angle. And how are we going to determine that? So, from all the information we've gathered so far, we can use our FunX. So if you haven't watched the video on different types of angles, please go back to that and look at FunX, and then you will know what I'm referring to. But if you haven't, then you know that this side is parallel to that side. So you can use the F, the U, or the Z in this case. I like using the U, so there we've got a nice little U forming between that parallel line. There's our bottom, and there's our next parallel line, and therefore we know that blue plus red is equal to 180 degrees. Then you will obviously be able to determine blue. So the other way to do that is to extend this one, and then you've got an F with the exterior angle here. This angle here will be the same as that angle there. And that is basically the properties that you can determine. The same is if they give you the length of this side, you can determine the length of that one. If they give you this one, you can get that one. Okay. Very important to know that you can use all the knowledge that you've got already from a different module and apply it to these. Don't forget that, guys. You are allowed to use all the knowledge that you have gained over the past 8 years to do all of this. Use the algebra, use your logic, use all of those things. That doesn't go to waste. Okay, next up we have the rectangle. Okay, so rectangle is one of the first shapes that you were taught when you were still in kindergarten. That means pre-primary, grade double R, triple R. So a rectangle is the easier one. It's the one that you should know off by heart. So let's look at it. There's our rectangle, nice and big. Okay, what are the properties of a rectangle that you already know? You know that all angles equal to 90 degrees. So how do we indicate that an angle is equal to 90 degrees? We make little squares in the corners. Okay, usually it's just indicated with a line like that and that, but it actually forms a little square. You'll never find it being like in the shape of a rectangle. It will always be in the shape of a square. So all angles equal to 90 degrees. That is how we show they are equal to 90 degrees. The next property that you know off by heart are opposite sides are parallel. So how do we indicate parallel lines again? With arrows. So there's our first pair of arrows. So if this pair is single arrows, then our next pair will be double arrows. So opposite sides are parallel. The next property that you know off by heart is opposite sides are equal in length. Therefore, those two are equal. One line, singular line. Therefore, our next pair will have double lines. So those are the properties that you need to know by now. In grade 10, 11, and 12, you learn a lot more extra properties of the rectangle, but these are the ones that you know already, and now you can actually use them to determine a lot of other things. Okay, next up we have the square. Again, square, one of the first shapes that you know. And what is the square? What are the properties of a square that you should know? So the first thing first, you know that all angles are 90 degrees. Secondly, you know that all sides are opposite sides are parallel. Therefore, top and bottom, left and right. So there, left and right, single arrow, top and bottom, two arrows. The next one says all sides are equal. So in all the ones that we've done so far, we've only used single and double lines because the sides weren't all equal. In the case of the square, all the sides are equal, therefore we can put single lines on all four sides to indicate that all of them are the same size. and that is your square. Our trapezium. Okay, so I said earlier that the trapezium card doesn't always look like this. Unfortunately, Windows doesn't have the option to make the line there. I wanted to give you a little silly one. But this line here or that one there can be a little more skewed like that. Sometimes this can even be a 90-degree angle with a tiny one at the top and go down like that. But the only property of a trapezium that you need to know, and this is very important, it only has one property that you need to know, and that is this one. One pair of opposite sides are parallel. Only that. So in this case, it will be your top and bottom. So if you have a shape where you can only see the top and bottom are parallel and it is a quadrilateral, it will be a trapezium. It's the only one that you need to know. Okay. Next up we have the kite. So the kite has a lot of properties and I love the kite because of this. And you don't need to know all of these, but I want to show you that for these kind of shapes there's a lot of extra properties that can be used. So the first thing we look at is two pairs of adjacent sides are equal. So adjacent means next to each other. So two pairs of adjacent sides are equal. So this side is equal to that side and the long side is equal to the long side. Okay, so in this case this side is not equal to that side. Okay, even though they are adjacent, it doesn't mean they have to be equal. The adjacent sides will be the sharp corners. Okay, so there you've got two sets of adjacent sides are equal. Next up we have the diagonals intersect at 90 degrees. Okay, so if we draw a diagonal is a line that connects two vertices. So there's your two vertices. So they always intersect at 90 degrees here in the middle. Very nice property to know. Again, this is not one that you need to know right now, but it's nice to know. Then the long diagonal bisects the short diagonal. The reason I put this one in here is to teach you the word bisect. Okay, so we're going to look at that one again later though. So bisect means that it is cut into two equal parts. Bi means two. So if we cut the long diagonal, cut the short diagonal into two equal lengths. So this part there up to there is the same length as that one there. Okay, very interesting to know, and you can obviously use it later. Okay, next up we have the rhombus. Rhombus is a special type of parallelogram because this only property that makes it special is that all sides are equal. Okay. The next up we have opposite angles are equal. Again, opposite each other and opposite each other. They have to shake hands to be equal. The next property, the diagonals intersect at 90 degrees. There's your two diagonals and they intersect at 90 degrees here in the middle. That means that four right triangles are formed, eh? Right angle triangles here. Okay. And the diagonals bisect each other. So in this case, here where the diagonals intersect, it cuts them into half. So the first pair, those would be equal, as well as these two, they are equal in length. Okay, again, nice property to use. And that's that. That is all about your quadrilaterals. And I do hope you've enjoyed this video. Please let me know, comment, like, and yeah, good luck.